Hi everyone, I'm going to make you a quick guide on how to do an analysis. So I've got data, and the question in investigation was the essence was to see if a revision has an effect on test scores. So here is the gathered data. The difference between the two medians is 19. There we go. Upon inspection, it looks like the treatment. And so this was a treatment applied where revision was given to the treatment group before they did a test. The test was rated out of 100%. The control group, of course, did not get the revision time or the revision techniques, etc. So, in essence, the theme was revision for this experiment. So, the treatment group got a median of 19%. So the difference between the medians between the control group and the treatment group is 19%. Now, very quickly, I will do a box and whisker plot. So here's a box and whisker plot. As you can see, upon inspection, literally, seriously, the treatment looks really good, isn't it? You've got all values shifted more to the right in the control group. But we don't know if this is happening purely because of the revision technique, or is it just random chance? Is there chance at play? So, which is why we do the re-randomization test. Now, I'm going to take a minute or two to explain this. So, feel free to fast forward this video if you don't want to, or if you understand what goes on here. So, what this does, if I randomly, so what it does, it takes your 10 control group items and 10 treatment group and randomizes them. So, imagine if you take these 10 control group and 10 treatment, if you put them in a bag and you don't see and you shake the bag and you go, you know what, I'm going to randomly assign each one of these to a control group and treatment group. So watch what happens here. If I do this once, see how the colors are removed and they're just put into random groups. And if this arrow here points to the left, it now is giving a median where the treatment group's median is actually smaller. So that's negative. An arrow to the left is negative, an arrow to the right is positive. So this time the difference is much less than 19, of course. Try that again. Got a different one, and so on. This is totally random, of course. This time I got an arrow pointing to the right. So this gray arrow here is saying the difference between these two groups' medians is now positive, and it's, I don't know, some number. Looks like 50, 60, maybe 15 or 16 or something. Anyway, so what we're going to do is click on stop. We're going to do a re-randomization test. Please watch the video on the PowerPoint which I shared with you. So what it's doing is every time this gray line here is finding the difference between the mediums and plotting them here. So these are all the DBMs plotted on a dot, like a dot plot. If I show the tail proportion, there it is. I'm getting 72 out of 1,000. Now I have done this beforehand, and I got a tail proportion 79 out of 1,000 or 7.9%. So of course, because of randomization, it'll be different. Now, in your analysis, do your graph like this. You can call this the data graph, the actual, say you can call this section 1, section 2, section 3. Don't just call them section 1, section 2, section 3. Please do give them meanings as to what it stands for. And here is a little blurb on what I have done and my intention to use re-randomization. Feel free to pause the video and read, please, and why I'm going to do it. Right. I have left a text box here for re-randomization blank. I would like you to write your own understanding as opposed to just copying and pasting or reading something and just copying it word for word. What is your understanding as per the context here? What is re-randomization doing? State its purpose, state the process this VIT module does, what it does. So state it down in this portion here. And if you look at the marking rubric, it says here you're writing a statement to explain what re-randomization does. When it says a statement, it doesn't mean a sentence, okay? You gotta do quite a bit of writing. And you're gonna clearly link this to the null hypothesis. The null hypothesis, by default, is you stating the chance is at play. So my null hypothesis in this case, with that symbol there, that's a subscript 0 with an H. That's the symbol for null hypothesis. The observed difference between the medians of the control and the observed difference between the medians of the control and treatment groups test score is due to random chance alone. That shouldn't be test scores, it's test score, okay? So once again, that's the null hypothesis. Now, the null hypothesis is always stating that any difference is due to chance, because that's what you're testing here. Now, according to the our graphs, we can see that our tail proportion is 7.9%. And that is greater than 5%. So what it means is what does it mean? Do we have evidence to reject the null hypothesis or accept it? If it's greater than 5%, we will accept the null hypothesis. So what I've written here, re-randomization showed that the observed DBM test score of 19% or more occurred around 7.9% of the time due to chance alone, okay? So that portion there is really important. Since this percentage is larger than 5%, the cutoff, I can conclude that there's insufficient evidence to suggest that the outcome of the experiment was due to the treatment. Can you see if, like, let's just say, for example, if I had a number such as 2.9%, then of course you will reject the null hypothesis in this case. If it was, say, 2.9% because it's less than 5%, but you can't be fully confident. All you got to do is say you've got some statistical evidence to suggest that the treatment is having an effect. Of course, this is a small scale experiment. If you really wanted to do a proper, legit experiment, if revision was having any effect on test scores, you would do it in very different conditions. You'll have much more controlled environment. You'll have larger test subjects or experimental units and so on. So here's my brief conclusion and my null hypothesis. So this is a mini structure you can follow. Now, to gain that excellence, please, you don't just answer the question. You got to justify all findings, or you can clearly link all findings to the research. When I said link findings to a research, it's not because this article said so. Yes, this article said it, but what does it mean? What does it mean to you? So what? Be critical. And of course, to gain that excellence, you are doing a lot of reflection, discussing, say, potentially how sources of variation were dealt with, and so on. So, look, this should really set you up well. So, I'm going to actually post a blank Google document on the classroom page, and I would like you to just copy paste it there. So, I want it officially submitted to me in the classroom page, okay? I will put my document as a guide on the classroom page, and yours, the documents you shared with me, just copy paste whatever's in there. So I wanted a formal submission on the classroom page, so there is some kind of tracking, okay? If you have any questions, please do email me, but that should set you up well. Now, the planning aspect, make sure you are meeting each criteria, please. If you have missed taking photos this time, may this be a wake-up call for you. You need to have some form of evidence, filming, photographing, that you have conducted the experiment. Research, you guys are in level three, pursuing level three qualification. So, formal writing, you would know how to do research. Some form of referencing would be great. Don't just copy paste from the website or a book or internet. You actually need to rewrite and ask yourself, what does it mean relative to my experiment? What does it mean in my context? What is same? What is different? What does it mean? So yes, dig deeper, please. Okay. All right, Toodles. Thank you.